Hi, welcome back to Null Zero Labs. Today we're going to build out from where we left off a couple of days ago, where we built our topology for one of our data centers using MLAG chassis on Arista and 3 top-of-rack switches. We're going to add a secondary data center to the mix. We're going to get VXLAN set up, and we are going to bring our VLAN across into our secondary data center and have all of our servers talking in each of our cabinets as if they are on the same subnet. So if you want to check that out, remember to like and subscribe, and let's jump in the lab and take a look. So here we are in the lab. Now remember last time we had this lab open, we used our Ansible playbooks to build out this MLAG Arista topology in what is now data center 1. And we had our 2 core switches that were just acting as our aggregation, and we had our top of rack switches where we had 3 cabinets, where we had a server in each switch on VLAN 10, and each server needed to talk to each other, and that was all working and how we left it. Now I want to add this second data center to the mix. And what I'd like to do is build it out again. It's going to be an identical topology. We're going to have our aggregation / core switches, and then we're going to have our 3 top of rack switches that again we're going to have 3 servers in, and we want them to be able to talk to the servers over in data center 1 as if they are still on the same subnet, so i.e. layer 2. So we're going to enable VXLAN across 2 cross connects between our data centers here, and we are going to be able to extend the VLANs over into data center 2 to allow that to work. So let's start building out the topology in data center 2. So we know that we are going to need a few Arista switches, 5 of them to start with. And we'll start these all with DC2-SW. There we go. So that's the lowest one, DC9. 12, 13, 14. So 13, 14. So these 2 will be our core and aggregation. And then these will be our top of rack switches. We're also going to need a couple of Linux boxes to act as our hosts. So we will use just our server ones. We need 3 of those. DC2 -node -. Okay. 15, 16, and 17. So let's wire this side up and get everything functional, and we will add the management network. And then what we will do is we will use our playbooks again to get this part operational, and we'll test that our nodes here can all communicate with each other and that everything is all functioning. But obviously we won't be able to communicate with the stuff that's over in DC1. So what we will do is we will then add our VXLAN cross connect. All right, so we also need some management clouds. Management. We're going to need 5 of those, because each one of our switches has a management interface. So 1 for you, 1 for you, for you, 1 for you, and 1 for you. This stops you having to have cables going all over the place to link up into the management network, so makes it tight. So let's connect up all the management interfaces first. So we know we've got those all hooked up. I wasn't too sure whether or not I should do these sorts of things as like a live, you know, where I'm wiring stuff up, or whether or not people just want to see it in the video format. It's like sometimes it's not. I'm a bit uneasy about whether or not we should do it as a live, especially when we're doing stuff like this, or if it should be a video. But it's just that sometimes when you're doing some of these things like this, it can be lots of periods of where you're quiet because you're just looking at what you need to do. Right, so that's our management interface is all connected. So now let's do our peer connection. So we will use 7 to 7 and we'll use 8 to 8. We obviously don't have to, we can change that in our playbook to use a different interface, but we'll just keep them consistent for the time being. So there's our, whoop, there is our core / aggregation. And now let's create our MLAGs down to our switches. So we'll use port 1 to that one. Port 1, so we use E1 and 1 and 2. Port 1 to that one. Port 2 to that one. Port 1 over here. And port 2 over here. Those they stop moving around. Okay. Right, so there is our aggregation / core and our top of racks, and we'll connect each of our servers to port. Let's do port 3 on each one of these. Okay, so they are all connected as well. Let's label them up with an IP address so that we know what they are. So we'll duplicate that. So this one is going to be, let's just continue up. This will be 4. This will be 5. And this will be 6. So 6 servers in VLAN 10, split across 2 data centers. Okay, right, so let's get the aristas fired up and we'll get the zero touch stuff all disabled. And then we'll come back when we're ready to paste our management access configuration on. And then what we'll do is we will then jump over into VS Code, we'll push a playbook against these and get them so they're operational just like how in DC1 is. Okay, so all of our switches are now booted, they're ready for their minimal config, and all of our nodes are online, and I have assigned them all an IP address off camera just to save time. So this is .4, 5, and 6, and they are all online. So now let's do the minimal configuration again on all of these, bring them up, verify that all of our nodes can ping each other, and then we'll then look at doing the layer 3 cross connect between the two, and we'll enable VXLAN and be able to extend the layer 2 VLANs over the layer 3 network. So let's get management config. So our minimal management config, we will use 3 and 4 for this switch. So that is switch 9. So I'll paste that in. And we want 4. For our secondary aggregation core switch. And then what we will do is we will use, we did 10, 20, 30, didn't we? 10, 20, 30 for the top of rack switches. So we will do 10, 20, 30, we'll do 40. Your management address will be 40. Yours will be 50. This is just so that we can get them all reachable via, and the last one will be 60 via our Ansible. And then we will then make sure that it's all online. Otherwise, we'd have to sit there and type this all in, which we don't want to do. 14. Paste you in. Okay, so all of our switches in data center 2 now have management access set up. So let's jump over to our VS Code. Let's look at our play. This time we're going to run it against these ones. And we will call this, SW1B. We're going to run that between SW1B and SW2B. This is for our MLAG course. Now let's look at our configuration. So SW1B, VLAN 10, 7 and 8 are our peer channel. Doesn't matter about the channel group, it can be the same. We're going to use the same VLAN ID. I don't think that really matters. I think we can still use the same VLAN ID. We're going to use a different IP address. So 1B will be 5 and our peer will be 6. We've changed our domain ID, so we're in a different domain. And we've obviously got, we are 103 and we're going to talk to 104. That's correct. Management VRF, and then our MLAGs down to our others. Ethernet 1 is in MLAG 1, 2, 3. That'll be the same on each switch. We look again on this one, SW2, VLAN 10. That all's the same. This can all stay the same. With this time, the IP address is 6. We're talking to 5. And we are talking to the heartbeat address of 103, which is the one on the other side. And our MLAG interfaces are configured. So we should be able to run this play again now against those two switches. And that should get our MLAG chassis set up for data center 2. And we'll confirm that once it finishes. Okay, it's doing MLAGs. Right, so that's done. So this should now be configured as a chassis. Let's look at both switches. Show MLAG. So we see our MLAG domain DC2 is up. Peer address is working. Active, it's negotiated. We have our 3 lags, but obviously they're inactive at the moment because we haven't configured the top of rack switches down here. Let's get these ones set up. So if we jump into VS Code quickly, if we duplicate one of these, if we copy this, and then if I copy, and we will paste. There we go. So rename. We'll call you SW1 B. W2B. SW3B. So SW1B. We're going to use VLAN 10. We are using port channel 1, 1 and 2 are going up, and E3 is our client. So SW2B. Where are you? SW1B. Yep, that's correct. SW2B. I put a SW2B and SW3B. That's the one, sorry. So that would be SW2B, VLAN 10, port channel 1, E3, SW3B, and you're going to be VLAN 10, port channel 1, 1 and 2 are in the VLAN, in the port channel, and E3 is going to be our access port. So that's that. Let's add them to the inventory. So we'll copy you. And you will be now SW1B. And we said that the management address was 40. Duplicate you again and again. 3B, you were 60. You were 50. And you were SW2B. Okay, and now we will run this playbook against our NAD underscore SW1B, B even, and NAD underscore SW2B, and NAD SW3B. Now that should configure the host name, configure the port channel, create the VLAN, and set up the switch ports. So we will now run that. So that will now connect to our 3 switches over in data center 2. Configure port channel 1 up to the chassis, and configure VLAN 10, and configure our node on one of those ports for us. So now, if we jump onto one of these, there we go. And null 0 labs, show int status. 1 and 2 are our port channel members. That's correct. Port channel 1 is the trunk, and port 3 is our client access port in VLAN 10. Show VLAN. So we should now jump back to our 2 core switches, show our MLAG. We should see that we have active full MLAG interfaces. There we go, our 3 MLAGs are up. So we've now brought data center 2 online. Okay, so that's all looking good. Let's double check that our nodes down here can ping each other. And then we can then work on connecting our 2 data centers together over layer 3 and enabling VXLAN to make sure that our VLAN 10 is just able to work across all 6 of our cabinets now in 2 different locations. So now from here, if we ping 192.168.10.5, that's the one in the other cab. 10.6, that's the one there on the end. That works. Obviously, we can ping ourselves, but we shouldn't be able to see or hit anything over in data center 1. Nope, nothing. 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 Perfect. Okay, so all of our switches are back online, and I did decide that we'll add 2 routers in just to show that they are going via a routed link rather than connecting directly. So we've got 2 suppliers that are giving us connectivity. Obviously, it's only 1 router for each leg, but obviously it could be going through an entire routed network to get between these 2 data centers. All that we need to maintain is that we have a jumbo MTU path between A to B. So let's start by configuring our layer 3 connectivity and check that we can get from each side to the other. We're then going to set up some loopbacks, a redundant VLAN with layer 3 so that the 2 local switches can communicate with each other. And then we will then add the VXLAN part on top and span these VLANs so that we can get some connectivity between all of our cabinets. So let's start on switch 1 and get the Ethernet 4 configured for this connection here. So let's log in on switch 1, this one here. We want int E4. Description, DC2 -L1. We'll just call this via link 1. Its IP address is going to be 213.0.1.2. It's a /30. Oh, no switch port command first. Then we'll put the IP address. So we've given it an IP. MTU needs to be 9, what was it again? 9214, that's what I thought, 9214. No shut. Show run int E4. Description, MTU, no IP address, blah, blah. Let's enable IP routing. We are going to need that. Let's just ping 213.0.1.1. 213.0.1.1. Okay, so we can ping our ISP's gateway interface here. Perfect. Let's do switch 2's interface. Config T, int E4, description, DC2-L2, this is the secondary link. MTU is, what did we say again? 9214, wasn't it? 9214, no switch port. So we turn it into a routed interface. IP address, 213.0.2.6/30. No shut. IP routing. Ping 213.0.2.5. We can reach the gateway address. Save that. Let's move over here slightly so we can see. So again, let's do this switch here. It's going to be 213.0.1. This is obviously 5, so this one's going to be 6. And we log in. In E4, description, DC1-L1, this is our link 1. MTU was 9214. No switch port. IP address is 213.0.1.6. It's 30. No shut. Enable IP routing because we are going to use that. Ping 213.0.1.5 can reach the gateway. Perfect. So I'm going to save that. Let's look at this one. It's going to be Ethernet 4. It's got this subnet. Right, admin. Mozilla Labs config T int E4. Description DC1-L2. MTU was 9214. No switch port mode, and an IP address of 213.0.2.2/30. No shut. IP routings, we're going to need that, and ping, what do we say, 213.0.2.1. We can reach the gateway. Okay, so we have basic connectivity there. Let's set up OSPF and get these networks advertised so that each of our switches can see that. So let's do if we jump on to, let's do the left side first. So switch 1, this one here. So we want a router OSPF. We'll just give it an ID of 1. Router ID is our router ID. The network we are going to advertise is going to be 213.0.1.0/30 into area 0 to 0 to 0. We'll come back and we'll do the loop backs and stuff like that in a minute. So that's that one. Let's do this one. OSPF 1. Router ID. Now I think the router ID stays the same on. Let's give this one 1.1.1.2 as our router ID. So we know that that is router 2. The network was 213.0.2.4/30 into area 0 to 0 to 0. And the max-LSA was 12.123. Okay. Let's jump over onto the other side, which is DC. Actually, we're going to have to do it on here as well. So let's do the switches first. So DC switch 9, router OSPF 1, router ID. We'll use 1.2.1.1. Network will be 213.0.2.0/30 into area. Okay. Okay. And this one, router OSPF 1, router ID 1.2.1.1.1.2.1.2. Network was 213.0.1.4/30 into area. Okay. Save all of those. Let's quickly jump on our middle routers and set up routing on here. So far we're not advertising anything. Good, so we'll save that. Check this one, show IP OSPF neighbors. We have 2 and they're in a full state. Show IP route. Obviously we're not advertising anything, so save. Back over onto the switch, show IP route. It has a route there. Switch 2, show IP route. It has a route there, so we should be able to ping 213.0.2.1. Yep, so we can reach the other side, so 2.2. We can now reach from switch 2 on the left. Via this interface, we can now reach this interface because we've got a full routed path. Let's have a look on switch 1. We should be able to ping 213.0.1.6. Yes, we can, which is this one here. Okay, so we have all of those. So next, we're going to need a loopback interface. So we need a loopback. So switch 1. Can I pop there? Go on. That's it. So there we go. Switch 1. This one on the left. So config T. Int L0. IP address. Let's do. What did we use? Let's do. So int L0 IP address will be a 10.0.0.1 /32. Okay, and then we need a backup path. So we'll do VLAN 1001 int VLAN 1001 IP address. And we will use another one of these. We'll use 10.253.0.1 /30. Jump over and switch to config T VLAN 1001 int VLAN 1001 IP address 10. What did I say? 10.253, wasn't it? 10.253.0.2/30. No shut. Router OSPF 1 network 10.253.0.0/30. 1 network 10.0.253.0.0/30 into area. Okay, so that should come across there. So we show int trunk. VLAN 1001. Yep, okay, that can go across the port channel, so that can reach each other. So ping 10.253.0.1, which is this side, 0.2 is the other side. Perfect, so we have IP reachability between the two. Okay, what next do we need? So we should do that on the other side as well. So we'll do the VLAN between here and we'll do the loop backs. So if we do, let's quickly jump back over and switch 1. Bring you up 2 bit, there we go. Show IP int brief. So that's our backup path between our switches. We have our loopback 10.0.0.1, and the other one is 10.0.0. 2, I think. Show IP in brief. We haven't done a loopback on there. Config T in L0. We need a loopback. We've done that, and then we also need to advertise the loopback. Let's double check. We don't need the loopbacks to be the same on both the switches, do we? Well, where we there? A loopback interface is created and assigned an interface and must be the same on both switches in the MLAG pair. Okay, so within the MLAG pair, we have to set the exact same loopback address as what we've used on this one. So we're going to use this one for the ones on the left. So we're going to use the same IP address. Show IP in brief. So it has a loopback. It has a backup path. It's got its uplink via E4. So now show run router OSPF. Show run. There's the root. So we are advertising the backup path, the path to ISP. Now we need router OSPF 1. Network will advertise our loopback, which was 10.0.0.1/32 to area 0.0.0. And we also need to advertise our, no, that's it. So loopback network, backup path, and uplink. Okay. Write that. And then on the other side over here, config T, router, OSPF 1, network 10.0.0.0/30. Oh no, 1/32 into area 0.0.0. Yeah, we advertise the loopback in, show IP OSPF. Show IP route. Loopback is directly connected. That's fine. So we're both advertising the loopback address out. So if we jump over to this side and show IP route, we can see the loopback via this path. We can see that backup path. Okay, let's check the other side. So show IP route. Yeah, we can see the loopback address as well on that side. Okay, so now let's advertise this side. Show IP in brief. So we have a management interface. We have our peering one. We have our uplink to ISP on here. Show IP in brief. So we're working on these two switches over. No, we're not. Yeah, working on these two switches here. So that's got its uplink thing. So we're going to put a loopback and a backup path between the two. So let's do that first. So config T, VLAN 1001. That'll be our backup path. We'll name it later. Int VLAN 1001. IP address. Let's do, what did we use on the other side? Let's do 10.253.0.5/30. We'll do that on this side, the other side, VLAN 1001, int VLAN 1001, IP address 10.253.0.6/30. And now for our loopbacks, which have to be the same on each side. So int L1 IP address, we will use 20.0.0.1/32. And we'll do the same on the other side. So int L1 IP address 20.0.0.1/32. Show IP int brief. We have a loopback. We have our backup path on this VLAN between the two that gets carried on our peer trunk. And we have our uplink on E3. And then we look at the other switch, show IP int brief. Again, we have our uplink to our ISP on E4. We have our loopback address. And we have our backup path on VLAN 1001. Okay, so now let's advertise that. So router OSPF 1 network. Let's do the loopback into area 0. And we will do network, the backup path into area 0. Save that. Jump onto the secondary one in DC2. Router OSPF 1 network. That network area 000 and a network for the backup path. That area 000. Save. Right. So now switch 1 on the left in DC1, we should be able to ping 20.0.0.1, which we can, which we'll use for the VTIP endpoint. So we've done all of that. So we've done our loop back, we've done our path up to our ISP, we've done our backup path VLAN between the two. Everything's all in OSPF, and we're advertising our loop back so we can see that. So next is create our, all we should have left to do, check the documentation, is just to create our VXLAN interface. That should be it. In VXLAN 1. So on this switch, our VXLAN source interface is loopback 0. Our VXLAN UDP port was 4789, and our VXLAN VLAN was 10, and we're going to bring that over on VNI. Let's do 10 and 10,000. 1, 2, 3, 4. Yeah. And our VXLAN flood VTIP is going to be the one over on this side, which we said was 20.0.0.1. That should be it. And we will put that as well. Copy that. That'll go on to switch 2 in DC1. So we've configured the VXLAN interface on this side. Let's do the same now on this side. It's loopback 1, so we've got to remember that. So config T VXLAN interface VXLAN 1 VXLAN source interface is L1. And then our VXLAN port, UDP port, was 4789. And then our VXLAN, VLAN was 10, and the VNI for that was 2, 3, 4. And then finally our VXLAN VTIP for that was 10.0.0.1. Show VXLAN VTIP flood VTIP. So that is on there. Show MAC address table. Okay, I'm going to save that. Let's do this side. So config T, int VXLAN1. VXLAN source interface was L1. VXLAN UDP. VXLAN UDP. VXLAN UDP port was 4789. VXLAN VLAN was VLAN 10, and the VNI was 1, 2, 3, 4. Is it 4 zeros or was it? 4 zeros, isn't it? Put it wrong. Make sure that matches. That has to match. One, 2, 3, 4. Yep. And yep, that looks good. So save, 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 and save. Okay. Show MAC address table. Okay, nothing in there so far. Show VXLAN. VNI. The VNI is mapped to VLAN 10. And obviously VLAN 10 can go across all of the port channels, port channel 1, 2, and 3, and across the VXLAN interface. So we should now be able to ping over to the other side. So we show VLAN on this side, we've got VLAN 10. This is all routed up here. So now if we jump onto node 1 in cabinet 1 in DC1, and we ping 192.168.10.4. Okay. Nothing coming across. Let's go and have a look. Oh, looks like I forgot to put the VTIP in on this side. So config T in VXLAN. In VXLAN 1, VXLAN flood VTIP, and it was 10.0.0.1. Yep, that's the loop back on the other side. Show run. That's correct. Show VXLAN VTIP. Yep. show VXLAN VTip. Oh, wrong device. Show VXLAN VTip. Okay, so that's on both of them. Let's see that side. Show VXLAN VTip. And that can see the other side. So they both got it there. Let's go and take a look. There we go. So we are now pinging from cabinet 1 in data center 1 over to cabinet 3 over in data center 2, and it's all going via layer 3, but they all see each other now. So switch 1, show MAC address table. There we go. So we've learnt about the MAC address over on this side. So if we have a quick check of this node, IP address, so if we look at the interface on this address for .4 is 50F00. So if we come over to our node 1 and we ping .4, 10.4, so we're pinging from here, cab 1 to cab 1, DC1 to DC2. And if we jump up to the switch and we have a look at the MAC address table, there we go. You see we learned about the switch over on this side, switch 1, learned about that MAC address via the VXLAN interface. So there we go. We now currently have our 2 data centers, our 3 cabinets in each data center, and we can now put individual devices into individual VLANs and span those VLANs across both data centers. Let's have a look at what's going across if we do a capture on our routers up here, and we should be able to see, there's the traffic. There we go, virtual extendable local network. So we can see it, VXLAN. So we can see the traffic is wrapped up in VXLAN. We can see its VNI ID as the traffic is traveling across. Sweet. Okay, let's start a capture on this one as well. So it's not going that way at the moment. As obviously we can see we're coming up from this node and we're coming over to this node. What I want to see is what happens if we break the connection here. So we've got traffic going across from node 1 to node 4, and it's working. We can see packet traffic going on the link. Let's cause a break in service. So let's do that by int e2, and let's do a shut. You can see traffic is still going. Now, if we look at the other link, we can now see traffic is taking that path between the 2 data centers. There we go, and we can see the VXLAN. So we can see it's an Ethernet 2 packet coming in. It's then being encapsulated with VXLAN, and it's then being carried across, and then it'll be decapsulated on the other side and spat back out again as a standard layer 2. And we've got traffic coming from this node over to this node. We'll leave those both running so that we can see them running across. And what I want to do over on this side so that we don't see it drop, I'm going to no shut that interface. Okay, and let me jump that router as well. So now we've got traffic going across. Let's E1 shut. Just want to see what if there's any drop at all. So I've shut one of the other links between the other layer 3 links, nothing there. That's all pretty good, so no shut. That's all going across as well. There we go. So I think both are pretty much down right now. Nope, there we go. Little blip, and we are back and operational again. Okay, no shut that interface. There we go. So we have got our 2 data centers operational. We used a little bit of Ansible to spin up our MLAG chassis in both locations, and we used our Ansible again to spin up our top of rack switches quickly. We got our test nodes in place. We got a test node in each rack. We then configured layer 3 connectivity on each of our switches. We advertised our loopback interfaces. We advertised our backup path, and we advertised our ISP paths, our uplinks into OSPF. We then set up our VXLAN interface. We mapped the VLAN to the to the VNI, and we then were able to carry traffic across, and we proved that by looking at the MAC address tables showing that the MAC address was learnt via the VXLAN interface. Oh, and just before we sign off, I was getting curious, just as I was about to edit this video. I was like, could I add a third data center with VXLAN if we just had a layer 3 connection and some routing? So I added a third data center up here. This PC is in VLAN 10, 192.168.10.30. It's connected to a switch which has 2 redundant uplinks. We've set up the VTIP interface, and we are connected to the 2 other locations. And so if I look at the switch on DC3, I can show the VXLAN address table. I can see I'm learning about VLAN 10 from the other VTIPs, VTIP 10.0.0.1 and 20.0.0.1, which is DC1 and DC2. I can show, here we go, here we can see the VLAN mapping again, and we can see that we are looking for these tunnel endpoints on our VXLAN. So if I jump over to DC3 and I jump on this node, I can ping 10.1, which is over in this data center. And I can ping 10.4, which is over in this data center, or 10.6. There you go. So you're not limited as just 2 data centers. You can add some other locations in as well. I just thought it was interesting. I just got curious whilst I was signing off. So there we go. That was an interesting one for today, where we managed to build our secondary co-location, get to use a little bit of our Ansible skills there to speed up the deployment of the 2 chassis and the top of rack switches. We then did a little bit of routing configuration on our 2 gateways and on our switches. We set up our VTIP, and we set up our VXLAN interfaces, and we mapped our our VLANs to our VNIs, and we successfully tested traffic between our 2 data centers across our redundant connectivity, and everything's all working. So I hope you found that interesting. I definitely did. It's something I'm going to carry on playing with. Next thing to look at is changing maybe our setup within our one of our data centers to maybe a more spine and leaf topology, and put like a border leaf section in there rather than doing it up on the cores there. We can put a border leaf section in there Then we can do our data center interconnect between the two border leaves and transmit our VNIs and etc. across that way as a test bed. So that may be something we'll look at next. But other than that, have a good week, like and subscribe, and I'll see you next time.